There were 6 tutorials this week. The attendance was very poor as usual. I don't know what's up with you guys. So if you haven't been to any of the tutorials, please watch these videos. And there's also a video giving the full solutions to all the 7 questions. So that's this video here, right? And there's also the typed solution, which is this one. And there's also the handwritten solution, which is this one, right? So please have a look at them. If you haven't been to any of the tutorials, please have a look. Okay, now the exam, I think I told you when the exam is going to be. I assume all of you know when the exam is going to be, right? Do you read my emails, guys? I sent you guys an email giving the date and the time and the place of the exam, right? Thing is the 25th, is that right? The 25th of May. So for the exam, the only formulas you need to remember are the ones here. The only formulas you need to remember are the formulas in this sheet, right? It's only 1 page. But if other things are to come, you will be given the formulas or you will be asked to derive them. So for example, with respect to confidence intervals, you are expected to know the derivations for all the one sample confidence intervals. So for example, let me go back. So if you go through, you're expected to know the derivations of these 4 confidence intervals. So for example, if I ask you to show that the 100 times 1 minus alpha confidence interval for the population mean is this, then you should be able to prove it, right? And similarly this is the 100 times 1 minus alpha confidence interval for the population mean when the variances are known. So you should be able to prove it, right? And similarly for this is the confidence interval for the population variance, and you should be able to prove it from the first principles and so on, all right? But the 2 sample confidence intervals, they will not be tested. I think they will not come in the exam, so you don't need to worry about the 2 sample confidence intervals. Okay? All right. Any other questions about the exam? The exam, you should know the time. As I said, you should know the time and the date and the place. So make sure you know where the place is. If you haven't been there before, please make sure that you do know where it is going to be, right? And the R coursework is due on the 20th of May, which is a Friday, by 11 a.m. And so please submit your R coursework to Blackboard before that time. And you can type your report. You can type your report in Word or LaTeX. Either is fine with me. But when you upload the report, please upload the PDF version. Whether you're using LaTeX or Word, please upload the PDF version of the report. Okay? And it shouldn't be more than 5 pages long. I will have the report marked within a few days, so you should get to know your mark before the exam. So if it is, the deadline is the 20th of May, so you should get to know your feedback and your mark for the R coursework before, I would say before 22nd or 23rd of May. You should get to know, right? All right, guys? All right. So, by the way, I do all the marking, by the way, for the course and also for the exam. So I don't use any teaching assistants for my marking. So any complaints you have, just direct to me, please. Okay? All right. Any other questions, guys? You guys okay? Any questions you want to ask about the exam or the R coursework? R, as I said before, R is a free software, so you should be able to download it to your laptop and use that to do your R coursework. And the R coursework is very similar to last year's R coursework. So if you go to the bottom of this website, you will see the solutions for the last 1, 2, 3, 4, 5, 6. Last 6 years R coursework and the solutions. So for example, the solutions for the last year's this is the solution for the last year's R coursework. And it's very similar to this year's R coursework. So if you have any trouble, just try to look at last year's solutions, right? Okay. All right, so let's go back to where we are now. Now we are in week 9. Yeah, this is week 9, yeah. So I ask you guys to watch this video. Did you guys watch this video? Did you guys watch this video? Yeah, okay. So there are a few examples. I think there are 4 or 5 examples on, 4 examples. 4 examples on one sample confidence interval. The first one, you have IID normal with parameters theta and 1. We want to find a confidence interval for theta, and it turns out to be this. Are you okay with this example? Were you okay with this example? Give a shout. You should, feel free to give a shout if you're not okay. Example 2 is here you have IID normal with 0 mean and variance theta squared, and find a confidence interval for theta. So it turns out to be equal to this. So I used this property here. The property I have used is this property, which is, I know some of you asked me about this. This property is there are 2 different properties on chi-square distribution. Let me go back to this. Okay, I think some of you are confused about this, because if you go to which week is that? Yeah, week 3. If you go to week 3 and look at the properties of chi-squared, right? There is this property 3, which says that the sum of the deviations from the sample mean squared is chi-squared with n-1 degree of freedom. And then there is this property 6, which says that the sum of the deviations from the population means squared has chi-squared with n degree of freedom. So these 2 properties, although they look similar, property 3 and property 6, they look similar, but they are different results. The first one, property 3, is chi-squared with n-1 degree of freedom. The number 6 is chi-squared with n degree of freedom. So you see the difference between these 2 properties. In the first property, the deviation is with respect to the sample mean. And in property 6, the deviation is with respect to the population mean. So that's why it's n-1 here and n here. So in this example which I did, I have used property 6. I have used property 6 to argue that this guy here is chi-squared with n degree of freedom and not n-1. You see why? Because we are assuming that the population mean is 0. Right? So I'm using property 6. I'm using property 6 here, not property 3. You follow me? I know some of you were confused about this, and you asked me some questions earlier. Are you guys okay with this or what? So you have to be careful about these 2 properties. They look similar, but they're not the same, right? Property 3, the deviation is with respect to the sample mean. In property 6, the deviation is with respect to the population mean. That's why they are different, right? All right, so that's example 2. Example 3, here you have IID from a distribution like this, and you're asked to find the confidence interval for A. Now, if I give you a question like this in the exam, I will give you a hint. Like in this example, it's not clear like how you can find the confidence interval without a hint, right? So I will tell you like first, derive the distribution of Z taken to be the maximum of x1 to xn, right? And using that, use that distribution to find the confidence interval for A. So without this hint, I don't think without the hint, it's really difficult to do this question, right? So I'll first ask you to derive the distribution of Z, which turns out to be this, and then use this to find a confidence interval for A, which turns out to be this, right? Okay? All right, and example 4. Example 4, here you have a random sample from a log normal with parameters theta and 1. Right, so if xi is log normal, I'm sure you know this property. If a random variable is normal, then the log of the random variable is log normal. So that's what I have used here. If xi is log normal, then the log of xi is normal. And in the second step, I'm using the fact that if a random variable is normal, then the mean of the random variable is also normal. So from this line to this line, I have used the sample mean property. That is, if you have IID normal variables, right, then their sample mean is also normal. Okay, let me show you where it comes from. Should go back to, I think it's week 2. Yeah, if you go back to week 2 and look at normal distributions, right? This is property. This is the property that you need to watch out, right? If you have property 6, which says that if you have IID normal, right, with parameters mu and sigma squared, then the sample mean x bar is also normal with mu and sigma squared by n. So this is the property I have used over here, right? So the log of xi is normal with parameters theta and 1, and therefore the sample mean of the log of xi is normal with parameters theta and 1 over n. So you see, I have used property 6 of normal. You follow me? Yeah? Once again, I think some of you asked me about this. So this is the property I have used to go from line 1 to line 2, right? And thereafter is easy. And finally, you get this as the confidence interval for theta, right? All right, so these are the 4 examples in the video. So some other questions you like to ask, sorry, in the 4 examples. You guys okay? You sure? Feel free to give a shout. You sure not okay? All right, so what I'm going to do, as usual, is to do further examples. So let's start with, let's start with example number 5. Okay. So here we have just one data point, okay, one of 1x from a geometric distribution with parameter p, and we want to find a confidence interval for p, right? So geometric distribution, I'm sure you did this in your first year probability course. So you should go to the very top. Go to this, right? The geometric distribution is given by this. This is the formula for the PMF, or the probability mass function of the geometric, right? And so one way to do it is to, so the PMF, okay, let me write it down, is P times 1 minus P to the power x minus 1, where x goes from 1 to up to infinity. So this is the probability mass function of the geometric, right? And the CDF, so this is the PMF, and the CDF, which is the cumulative distribution function, is the sum towards, you can show, I mean, it's not difficult to show that the CDF is equal to right. I don't expect you to know this, but I mean, you can show using the PMF that the CDF is equal to this, right? Right. Now, let me try to so what I'm going to draw here is fx on the y-axis, and this is, suppose this is 1, suppose this is 2, suppose this is 3, and so on. Okay, so, and this is 0 and this is 1. So you should graph this as a function of x, right? Remember, CDF is by definition, CDF has to be a monotonic increasing function. I'm sure you know that from probability 1, right? The CDF must be a monotonic increasing function, right? So it should look like, this, right? I mean, any CDF, it's not just this CDF, any CDF must be a monotonic increasing function, right? Now, what we are looking for is 2 points. We are looking for 2 points along the x-axis, right, such that the area between them, the area between these 2 points, right, is equal to this area. I mean, this area here is 100 times 1 minus alpha. So this area is, we want this to be 100 times 1 minus alpha percentage of the total area, right? Okay, so that means the area over here, we can take it to be, and the area over here, we can take this to be, I mean, one way to, I mean, there's no unique way to do this, but one way to do this is to take this area to be alpha by 2 and take this area to be alpha by 2. So the total area beneath the curve can be 1, as it should be, right? So let's, okay. So the question is to find these 2 points here, right? Is to find these 2 points, right? So let's call this, let me call this, say, A, and let me call this, just for the sake of notation, let me call this B, right? So in order to find A, we need to solve the equation that f at A is equal to alpha by 2. Remember, f is the CDF. At A is alpha by 2, which implies that 1 minus p to the power A is alpha by 2. So 1 minus p to the power A is 1 minus alpha by 2. So you should take the log both sides. A times log of 1 minus p is log of 1 minus alpha by 2. So your A is going to be log of 1 minus alpha by 2 divided by log of 1 minus p. Right? You follow me? Yeah. And similarly, in order to find B, in order to find B, so we found A so far. In order to find B, we need to solve that f of B. What do you think f of B should be? No.
1 minus alpha.
Yeah, 1 minus alpha by 2. Right? Because remember, if this area is alpha by 2, the area below this point must be 1 minus alpha by 2, right? So okay. So this implies that 1 minus p to the power b is alpha by 2, right? So taking the log, b times log of 1 minus p is log of alpha by 2, right? And therefore b is equal to log of alpha by 2 divided by log of 1 minus p. Right? Are you with me so far? Right? So what we have shown so far is that we have shown that the probability that x is the geometric variable, right? The probability that x is between a, which is okay. Now this does not this doesn't answer the question. The question, should go back to the question. The question is to find a confidence interval for p, right? Not for x, right? X is just a data, right? What we need is a confidence interval for p. So what you need to do now is to convert this into a statement on p. I'm sure you know how to do it, right? So you need to convert this into a statement on p. So here you have two inequalities. You have the inequality that this is less than x, and you have the inequality that x is less than this. So you need to convert this into, I'm sure you know the math for this better than I do, right? So if you do it, so you should bring log of 1 minus p in the middle, right? And you have to be careful because, remember, log of 1 minus p is a negative number because p is a number between 0 and 1, meaning log of 1 minus p is negative, right? Right? So, I mean, it's really easy to make mistakes like that, right? So now what do you think the lower bound will be? So what do you think the upper bound will be? Come on, guys. Which?
1 minus alpha, which will over x.
Yeah. And here is log of right. So once again, you have to be careful, very careful, especially when you should think the number is negative, then you need to change the inequalities around when you multiply or divide, right? Right, the next thing is to take the exponential. So exponential of yeah. All right, and the final thing is to change this to p, right? So once again, you have to be careful how to change this to p, right? So, so you have p in the middle, right? And the left-hand side will be 1 minus exponential of this, right? And in the upper limit will be 1 minus the exponential of all right? You follow what I've done, right? So clear, guys. Sometimes it can be tricky. You have to be careful about changing the inequalities around. It's easy to make mistakes, right? Okay. So hence, all right. So this is the final answer. The final answer to example 5. Okay. Any questions, guys? All right. So the next example, we have time here. So the next example I'm going to consider is example 6. Right. Right. So, so in this example, ln is log normal, as you know, right? We need to use a property which I just talked about. Let me go to big 3. Is it big 3 here? Yeah, big 3. Yeah, we need to use one of these two properties, right? Either property 3 or property 6. Now, we are told that xi is log normal with parameters 0 and theta squared, right? which implies, right, as I said a minute ago, log of xi is normal with parameters 0 and theta squared, right? Now we are told the mean is 0, right? So if you ought to use property number 6, right? According to property 6, right, log of xi minus 0, which is the population mean, divided by sigma, which is theta here, right, squared, do you see that, right? Because the population mean is 0, right, you can use property number 6, right, and say that this guy here must be chi-squared with n degree of freedom. Okay? So what I'm saying is that all right, or you can pull the theta squared outside. You guys okay? Right? All right. Now we can use this property to find the confidence interval for theta. I mean, I'm sure you know what to do next, right? So what this implies that the probability that this guy here right, lying between chi-squared n with a probability of alpha by 2, chi-squared n with a probability of 1 minus alpha by 2, right, is equal to 1 minus alpha. So remember, this is the percentile of the chi-squared with alpha by 2 to the area below, right? And this is the percentile with the 1 minus alpha by 2 to the area below. So between these two percentiles, there is an area of 1 minus alpha. Okay? Okay? Now changing this around is the same thing that we did before. You have to be a little careful this time, not so careful. If you bring theta squared in the middle, right, then the lower limit will be and the upper limit will be all right. All right, and finally, the final step is to take the square root. So if you take the square root all the way, you get this is the probability of the square root of less than theta, less than All right, this is equal to 1 minus alpha. Right, so hence, the conclusion, hence, 100 times 1 minus alpha percent Ci for theta is all right, guys, are you okay with this or not? Guys, any questions? All right, sir. All right. Okay, now let me ask you one thing. Let me ask you one thing, right? In the step from, in the line from this step to this step, right? When I took the square root, right? Normally, like when you say the square root of 4 is plus or minus 2, right? Or square root of 9 is plus or minus 3. Or square root of 16 is plus or minus 4. Right. Now, why did I not put a negative sign here? Come on, guys. I'm asking you a simple question. Like when you take a square root of a number, it can be a plus or minus, right? Yeah? Anybody? Anybody who has the answer? The reason is that, okay, if you go back to the beginning, right? It says this IID with log normal mean equal to 0, the variance equal to theta squared, right? So theta is the standard deviation, right? And in statistics, standard deviation cannot be negative. It must always be positive, right? Right? So when you take the square root of theta squared, it's always theta, not minus theta, right? Because standard deviation in statistics cannot be negative. I mean, by definition, it's a positive quantity, right? Okay, so that's the reason. That's the reason when I took the square root here, when I took the square root of all this thing here, they only put the positive roots because theta cannot be negative, right? Okay. You follow me? All right. So everything there is a reason, guys. All right. Now, so that's example 6. Next example, if you have time. Oh, next example, example 7. Right. So here we have two random variables, normal with 0 mean and variance sigma squared, normal with 0 mean and variance b squared, and we want to find a confidence interval for the square root of a squared plus b squared, right? Right. Now, so let me write this down. You have x normal with this, right? And you have y, which is normal with this, right? Now, I don't know if you remember the property that I talked about a long time ago. You should go back to week 2, right? You should go to week 2 and look at normal distribution. Some of the properties I gave you are this. Like, for example, if you have 2 independent normal variables, right? You remember this property that if x1 and x2 are independent, then their linear combination is also normal, right? You remember this, right? Yeah, so what you can say is that x plus y, you should take the sum of the two, it will be normal with parameter 0 and a squared plus b squared. That's because of property number 4, right? Okay, so now you should divide this by the square root of the variance. This will be normal with 0 mean and variance 1, right? Okay, so what this implies is that the probability right, remember, these are the percentiles of the standard normal distribution. So this is the percentile with area of alpha by 2 to the left, to the left for me, or below. And this is the area of 1 minus alpha by 2 below, right? So the area between these two is 1 minus alpha, right? Now what you need to do now is to convert this into a statement on square root of a squared plus b squared. This is why you need to be a little careful. You need to be a little careful. I will explain why. The square root of a squared plus b squared is a positive number, right? That's because a squared and b squared are variances, and variances cannot be negative, right? Right. So what you can do is you can multiply across by this guy here. So that's what I'm going to do next. So I'm going to multiply I haven't changed the sign because square root of a squared plus b squared is a positive number, right? Okay, now you should take this inequality here. What do you know? Okay, let me ask you, what do you know about this? Is it a positive or negative number? Z alpha by 2. Come on, guys. Are you lost or what? Come on. Let me show you why. How can it be positive? Why is it positive? Why is it positive? Because, let me show you what, right? Z alpha by 2 is the area below which there's an area of alpha by 2, right? So which side will it be? Will it be on this side or this side? Which side will it be? Yeah, so this guy here is negative, right? Do you follow me? Come on, guys. Are you lost or what? So alpha is normally like 5%. Usually it's 5%, which is 0.05, right? So 0.05 divided by 2 is 0.25, 0.25. So it will be on the negative side of the real line. Okay, so this guy here is negative, right? Okay, so when you divide by this is what you get, right? Now over here, this one here, is this positive or negative? Positive, right? Okay, so you divide this inequality by okay, right? All right, now this implies, so here we have a odd situation. We have the square root of a squared plus b squared greater than something, and the square root of a squared plus b squared greater than something else. So what does it imply? It implies that the square root of a squared b squared has to be greater than the maximum you follow me, right? Because if some number is greater than say 1 and it's also greater than 2, then it has to be greater than 2, which is the larger of the two numbers, right? Okay? So hence, the confidence interval, for square root of a squared plus b squared, the lower limit is that and the upper limit is infinity, right? Okay? Right? So that's the confidence interval. Is that clear, guys? So this is a little bit tricky. It's really easy to get this wrong. Really easy to get this wrong unless you realize that this number here is negative, right? So you have to be really, really careful when you get a question like this, right? All right, now, before you guys, well, I have a lot more examples to do, but before you guys, maybe I will give this as a homework for you. This is example, sorry. You need some homework, right, especially in the exam time. So this is example number 8. This is a homework problem. So suppose x is a and y is independent, right? find right. Can you do this question when you have time? And if you have problems, just send me an email 24/7. Okay, be happy to answer. Okay. All right, guys. So I'll see you later. Any questions? Just feel free to contact me 24/7. And also, if you haven't completed the unit evaluations, could you please do so ASAP, please? I would really appreciate it.
For a geometric example that
Yeah.
we did, you found confidence interval in terms of E, and it doesn't look like any of the given confidence interval formulas.
What do you
So
mean?
you have the given formulas that we
You
don't
mean
need
for
to
the
derive.
geometric? The CDF? You mean the CDF? Is that what you're saying? You mean this one here?
Yeah.
But
So the confidence interval. So for this question, you can't use any of the given confidence intervals, right?
no.
You have to derive it yourself.
Yeah, you had to derive it. Yeah.
Because it's not given for
No,
the
yeah. You had to derive it here. Yeah. See. Hello, how are you? Good. Hi. How are you?
This example, will the standard deviation be 2 afterwards, or does it still stay?
Yeah, the variance will be 2. Yeah, the
Variance, yeah.
Yeah, the variance
Standard
will
deviation will be squared.
square root. Yeah.
This variance will be 2.
Yes. Yeah.
So, it's negative and this is positive. So this is negative and this is positive. So we can only take this because this is negative.
No. It depends. It can be positive or negative because x plus y, x is a normal variable, y is a normal variable. So x plus y can be positive or negative. You don't know, right? Because you don't know.
X and Y.
Yeah, you don't know what the values of x and y are going to be because they can be either positive or negative.
X, Y. What is X, Y reference?
X is a normal, right? X is normal, which means it's normal distribution. So it can take any value from minus infinity to plus infinity. Right.
Okay.
Right, so x can take any value from minus infinity to plus infinity. And similarly, y can take any value from minus infinity to plus infinity. So x plus y can take any value from minus infinity to plus
So
infinity.
it means that if we take the
Yeah,
z alpha to the left side, 0 left side is positive. So we don't know which one is positive or negative.
yeah. You don't know which is positive, which is negative. That's why I took the max, because if this is greater than this, then it has to be greater than the maximum of the two. Yeah.
But that way we can't know this is negative or positive.
No, this is always negative, and this is always positive. Because remember, z alpha by 2 is the percentile on the left, and this is
So
the
we just don't know x plus y is.
yeah, you don't know what x
It
plus
can
y.
be negative and positive.
It can be negative or positive. X plus y, you don't know what the sign is going to be.
Okay.
But we know the signs of the z alpha by 2 and z minus alpha by 2. We know the signs.
Yeah.
Yeah.
Okay. Thank you very much.
Yeah.